Alright, so what I'm going to be going over today are sections 7 through 10. Yes, we know how to do a lot of it. My focus is not to think about it from the basic level. My focus again is to approach those test questions that will get you. Okay? Now, system of linear equations. A couple things that are big important things that you just need to remember. When you're graphing these, most likely on the test you're going to graph them by hand. You're not going to graph them with a graphing calculator. So we have to quickly identify how did we do this from Algebra 1. Find the y-intercept, which is -4 and 5. We go up, or do the slope as far as in this case, up 3 over 1. So positive 3. We graph it. Step 2, we have to remember when it's dashed or when it's solid. Biggest common mistake people make, bless you, is whenever when you are looking at graphs. Okay, so what I was talking about is the thing that people mistakenly go with these questions are two things. When these are too vertical, they sometimes don't know where greater than or less than. Or you might go too fast where you make the simple mistake of what's greater than or less than. Okay? The other thing is, and you'll see in just a bit with our example problems, is when the coefficient of y is a negative. Or any time throughout the entire process of getting y by itself, you divide or multiply by a negative. Because remember, we have to flip these inequality signs when that happens. So let's say that we have this steep line here, and this was y equals, let's say, 20x plus 3. That is what we just graphed. But then I gave you something that looked like y is greater than that. Just greater than, not greater than or equal to. Already we know that the line is going to be what? Dashed. Whoops, that's not dashed. So the line being dashed, now we got to say we will graph everything. We'll graph all the y values that are greater than this line. And sometimes people will scan it. They'll say, yep, the line is right here. This is greater than, and I'll be done with it. Just real quick, a visual. A greater than y value is pick any point on this line, anywhere. And I want you, instead of thinking up or left and right, I want you to think up or down. So greater than is going to be all the values that are above that, which you can just graph like this and be done with it. Okay? So the steeper the line, focus a little bit closer as far as to see how it's going to graph. Let's look at number 3. So number 3, it is not given to you in y is already by itself form. We want to do the minimum work needed to get the right answer. So in this form, I know it's going to be y is equal to. Because this positive 5 tells me I'm not going to end up flip-flopping this inequality because my coefficient is 5. So now I will subtract the x over. I hope you write that as negative x minus 4 and not negative 4 minus x, because we're trying to instill with speed what our slope and y-intercept are. Okay? And then at the end, what would we do? Obviously, divide by 5. So I hope you see it like this, but at the same time, from 5th grade, we know that this is broken up into that. A lot of the way it's tested on these tests, with this in mind, back in 5th grade, we learned that if we add things with the same denominator, that we will have a form that looks like this. All we're doing in a lot of ways, with polynomials, binomials, all kinds of different notations, is we're working backwards a lot. LCDs as well. These common denominators. So, anyone, this is my graph. What's my y-intercept? -4/5. So real quick, -4/5. You with me? It's close to -1. And the slope of what? -1/5. So down 1 over 5, down 1 over 5, so on and so forth. And all I'm going to do is graph what direction? Or shade what direction? Above it. So up, right? So here we go, real quick. We have all of this is going to shade. Because we graphed or shaded all the y values that were greater than. Now, this next one, it's not going to flip because of that 4 is positive. So I'm already thinking y is greater than. Subtract this 2x and divide by 4. Without me simplifying this time, anyway, what's my y-intercept? 1/2? Yep, here we go. So 1/2 is a little bit higher than this negative 4/5. Are you all with me? So here's 1/2. And what's my slope? Negative 1/2. So if I'm sketching this just real quick, and I want to help you out with this, I have negative 1/5 and negative 1/2. And I asked you to tell me which one's steeper. What would y'all say? So speed is a little slow. No worries. Multiply up 5 and 1, you'll get 5. Multiply up, you'll get 2. So this one is steeper. So I can look at this and know that my negative 1/2 is going to be steeper, and I can do a quick sketch. That's what I'm trying to show you, just a quick sketch, and it would be this dashed that looks something like that. Do I shade above or below? Above, because it's greater than. So above this line, not to the right, not to the left, but up or down, so above this line, all the shaded region that's overlap will be my answer. Okay? All of this here. Alright, that's just a quick review. That's enough of inequalities. Let's move on. Okay, solving for variables. Here we go. I have V is equal to 4/3 pi r cubed, which is the volume formula for a sphere. And I want you to solve for r. And the way that you'll see these on tests is a lot of times they'll say write r in terms of whatever the variable is. This means when you see in terms of, it's the same as getting this equal sign. Whatever letter's in front, that means get it by itself. And in terms of, variables go here. Real quick, this r is in terms of what? This r is in terms of v and r. What's this r in terms of? Just v. What's this r in terms of? V. And what's this r in terms of? V. Because pi is not a what? Variable. It's a constant. Okay? So these are just variables. Alright. So let's solve for r. What do we do to both sides? Okay, so dividing by 4/3 is correct. But what I would prefer you to do for other questions, including this one, is multiply by 3/4. Because I'm trying to get a cancellation of a form of what? 1. So this will become 3/4 v is equal to pi r cubed. Mathematically, what would I do next? Divide by pi. Dividing by pi is the same as multiplying by what? 1 over pi. So I'm hoping that you think of this because you know that 3v over 4, if I multiply that pi in the denominator over to the left, I'm going to be left with this. And last but not least, what would my last answer do? Or what would I do? Cube root. So cube root is the same as raising it to the power of 1/3 or getting what you see on D. Question? Question? Okay. Let's go now. See, look at all this. All this work can be a lot faster if you're doing those pieces that I was saying. First of all, from 1 through 6, which one do you all want to solve? Which one looks the most difficult? 5. You're right. So 5. We're trying to get, listen, V naught all by itself. And some of you, believe it or not, struggle with this, especially with speed. The reason why some of you might struggle with this is that you fail to recognize two things. Monomials versus polynomials. Okay? addition and subtraction versus multiplication. So, let's look at this. Multiplication exists here, here, and here. You tell me, how many terms did I box? 3. So some of you might be counting the variables right now, but there's only 3 terms because terms are separated with addition and subtraction signs. It's like there's 3 islands separated by water. Okay? How many terms is highlighted in orange right now? 1 term. Even though it feels and it looks like there's 3 different items, they're all glued together as one monomial by what operation? Multiplication. Alright, so here we go. Let's solve for V naught. Anyone, what would I do first?
You subtract R0.
Yep, I could subtract R naught. So that'll go away. Then what would you do? Subtract what? 1/2 AT squared. You with me? And what's the last thing that you would do? Divide by T. So that's the answer. Identifying terms by separation of addition and subtraction, and identifying monomials by separation of multiplication will get you fast with this kind of stuff. Alright, so real quick. How many terms do you see here? 2, 1, 1. Okay, so there's 1 there. 2, 1, and you get the answer. How about this one right here? 1. Good, because P is multiplied by that whole thing to have 1 term. Alright, good stuff. Let's go to number 10. Number 10, I'm going to try to isolate cosine of A. Here we go. Multiplication exists here, here, and here. A lot of people make the mistake that they think it exists between cosine of A. It does not. Okay. So with that being said, those multiplication pieces will be done last. So let's move stuff over. What do I move? The B squared. Could I do this? I could. Or I could move each piece at a time, which is still equivalent to what I have here. Okay? So now these go away. What's left? What's left to do? Divide by negative 2 BC. This is the cosine of A. Cool? Alright. Just wanted to reiterate terms of monomials versus polynomials. Alright. Let's see how fast you can scan now. What I want you to do, I think you should be able to do this in about 15 to 20 seconds. And I'm going to let the video still go. Which one of these cannot be written as y equals mx plus b? And when you think you know the answer, blurt it out. I'm hearing things. What do you see? D? How about A or B? Okay, so no A or B's. One of these is correct. Let's work on both so you can see. If I multiply both sides, what would I multiply both sides by what we've been talking about? What would I do right here? By a negative x, right? So multiplying by negative x, there's a cancellation form of 1. Negative x would give me a negative mx because multiplication does not have order. And if I move this over, this y, by adding it to the other side, I have what? Y equals, hold on, I moved the wrong thing. I have a negative y, I have b, I have a negative mx. My goal is to get y by itself. Yes, from here, I would move this one over, because a lot of people make the mistakes of negatives when they divide. I would actually add y over here and I would add mx to the right. Okay? If you don't, and you kept y over there, you might have forgotten that negative, and like last class or before lunch, they chose D as well. But the answer is not D. Okay? Looking at C, you would divide both by an m, so that you have b over m, which is left with this, and now if you got y by itself, you see b over m plus x is equal to y. C is the answer. Okay? So again, just practice with manipulations. Let's look at number 12, and I'm going to show you a fast way. Okay? Number 12 says, which of the following is the correct way for solving for y? Our goal is to get y all by itself. What should I do? Square both sides? Yeah. All right, here we go. Then what? Cube root. Cube root is the same as raising it to the power of what? 1/3. And you see why I'm doing that right now. Because on the left, I'm going to have x to the what? 2/3. Because we have to remember this algebra 2. A power raised to a power, we multiply. Okay? Otherwise, if it looked like this, then you would add. Which in this case is going to be 7/3. Go with me? Okay. But it's not this. It'll be 2/3 here. It'll be to the power of 1, so it's gone. And then last but not least, we're going to do what? Add the 2. Now look. Here's another yet example of what this revolves around. This revolves around inverse functions. Inverse functions, okay? If it's telling me to solve for y, that means I have to undo everything that's attached to y right now to get it by itself. And that concept stems from inverse functions. We learned it back in Algebra 2. This versus this. You may or may have not been shown in Algebra 2, a fast way to find this is not to flip the x and y and solve for the new y. A way you could do it even faster is to establish PEMDAS order first and do it in the reverse opposite notation. First of all, let's talk about this. If your y in normal PEMDAS, what's done to you first? -2. Then, y minus 2 is your running answer. What's done to you after that? You're cubed. Then what's done to you after that? You're square rooted. So a fast way to do this, and you would do this all in your head per se, is to do the backwards opposite operation here, here, and here. So here we go. I'm going to take just an x. And the first thing that I'm going to do is what? I'm going to square it. And the second thing that I'm going to do is what? Cube root it. And the third thing that I'm going to do? Add 2. D is your answer. Okay, so inverse functions is a way to solve for the variable. Okay, let's keep going.